is AB and BC cos. In this lesson, we will be studying limits. What type of limits? Specifically, we'll be studying limits involving E and Squeeze theorem and doing indeterminate forms of L'Hopital's rule. So, definition of E. We want a basic definition of E. What is E? E is basically limit as x approaches infinity. You must use this to solve these two problems. 1 plus a over x to the power x is equal to e to the power a. Look at this value here, a. This is very important. Limit as x approaches infinity of this entire function is equal to e to the power a. That's what it is. Now, remember, mathematicians has derived this from, okay, from financial point of view, it's like basically the force of interest. Like you're getting interest per second, so, or profit per second when you invest. Okay, so they give you a percentage and that's what you get out. So you'll use this formula. So this is one. The second definition, by doing some transformation, the second definition can be limit as x approaches 0 of 1 plus ax to the power 1 over x is equal to e to the power a. Okay, so these are the two definitions of E. All right, now let's solve this limit. We basically, what we are doing, we are solving limits involving E. So look at the first type, limit as n approaches infinity of 1 plus 5 over n to the power n. Remember what
to
is
the power
this?
of 5.
Good, because we can just see, we can see the form is type 1. So there's a 5 there. So it will just become e to the power 5. Okay, you're just directly applying this information inside here. You're not really using L'Hopital's rule to solve. But remember, there is a way to solve this. If you forget the definition here, you can use L'Hopital's rule at a later stage. What about the next one? Next one is, we see that is type 2, the second type.
Substitution.
No. This is the second type. Look at this. There's an a here, and that becomes e to the power a. We have the 2 here, and it's the exact same form as type 2. So this answer here is just e squared. Are we good, guys? Make sense?
Because I solved this using U substitution.
You can transform the limit and make it into L'Hopital's rule and solve.
I made it 1 plus 2x to the power of 1 minus 1 over x will be 1 plus u to the power of 1 over u times 2.
Okay, I will look at your solution at the end. At the moment, we're just directly applying this information there, that information there. Exactly what I have taught you, right? Next one, squeeze theorem. It's also called the sandwich theorem. Basically, what happens is you get limit from the left. If the limit from the left and the limit from the right approaches the same value, okay? Remember, squeeze theorem got to deal with something like this. So if you're approaching a limit, like limit as x approaches a, you got a value here, right? Just say you got a value of 1. And you got limit as x approaches a from the right, you're approaching from this side, and you get the same value. So the answer gets squeezed between two limits. So it becomes the same thing. Now, how do I solve examples? Most of the time, 99% of the time in squeeze theorem, you'll always have a complicated function with sine or cos, right? It's mostly sine and cos. Now, let's look at this example here. Limit as x approaches 0 of x squared times sine 1 over x. Now, if you directly substitute 0, what do you get? If you try to directly substitute 0, you will get undefined. But how do we start the problem? We say that sine x, what's the range of sine x? We always start with a range. The range of sine x is between -1 to 1. Okay? Isn't that the range of sine x? Minimum value and maximum value? Good. So now the range of any periodic function. What about the range of sine 1 over x? It is still 1, between -1 and 1. Because remember, amplitude is the number in the front. The minimum and maximum value won't change. If the only thing that you are changing is the inside. Now, what we do, we make the function look like this, x squared sine 1 over x. So what we're going to do now is we're going to multiply everything here in the two-sided inequality by x squared. So we get negative x squared less than equal to x squared sine 1 over x is less than equal to x squared. All I have done is I multiplied everything by x squared. You're allowed to do that in an inequality. You're not changing anything, right? We just multiplied everything by x squared. So I'm just highlighting that. Now what we do is we add the limit. We say limit as x approaches 0 of negative x squared less than equal to limit as x approaches 0 of x squared sine 1 over x is less than equal to limit as x approaches 0 of x squared. Okay, so this answer over here is 0, and this answer over here is 0. So you're not really solving the limit. You're solving the limit by using the range of the function. Okay, so you see the left-hand side limit is 0, and the right-hand side limit is 0. So the answer is squeezed between 0 and 0. So what's the middle answer? Middle answer is also 0. Do you get it?
0.
It
Yep.
has to be 0. Right, excellent. So that's what squeeze theorem is about. So what we say by squeeze theorem or the sandwich theorem, squeeze theorem, limit as x approaches 0, you have to say the answer is equal to 0 there, and you have to say the answer is also equal to 0 there. Let's write it out properly. Both the answers are 0, 0. So the answer is squeezed between two limits. Left-hand side limit, right-hand side limit, both zeros. So the middle part also becomes 0. Limit as x approaches x squared sine 1 over x is also equal to 0. Okay? By squeeze
Yeah,
theorem, limit as,
one
that's
question,
it.
sorry, Mr. Ghazali.
Yes, yes,
We do like this because if you replace the x by 0, we will take undefined, yeah?
yes,
That's why
yes,
we do
yes,
like this.
yes.
Okay.
It's a special technique of it's a special technique of limits, which is called the squeeze theorem. This is also a special technique of limit, which is called the E limit. Why? Because if you substitute infinity inside here, you're going to get 1 plus 5 over infinity, which is like 1 to the power infinity. This is 1 to the power infinity. You can't say 1 to the power infinity is 1, okay? It's an indeterminate form of, we're going to solve these questions by L'Hopital's rule later on. Look at this. If you substitute 0, now you're getting 1 to the power 1 over 0. It's like saying 1 to the power infinity here as well, okay? It's like you're getting 1 to the power undefined. Are we good?
Yeah, that's why, yeah,
Yes.
okay.
So that's the reason why we use a special limit. As long as it's in this form, that's a E limit. Squeeze theorem, because when you directly substitute, you're always getting undefined answers. So you have to find techniques of solving limits. And these are very two famous techniques of solving limits. And for squeeze theorem, there is no other way. This is the only way to solve it, right? But for this, okay, maybe L'Hopital's rule might work here, but we still have to investigate it. But here in for this E limit, you can use L'Hopital's rule,
Epsilon
which is
delta
our third.
proof.
No, 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 no. We're not doing epsilon and delta now. Wait, that is on the epsilon and delta is for limits of basic functions.
Yes, I
Let's
know.
do
I
that.
learned it last year in L'Hopital's rule. They taught me it.
Yeah, yeah, you don't need it now.
They
That
told me
is
that
just,
is the they told me that is the easiest way to solve squeeze theorem.
you can, but no need to do that.
Because
Just
I don't
use,
understand this way.
this is just using the range. I started with the range of sine x. Then what is sine x? If I draw the
The
graph
range
of
of
sine
sin x
x,
is negative 1, 1.
yeah, so what's the problem here? Multiply, then what's the range of sine 1 over x? Still
What
negative
happened
1,
with the
1.
x
Same,
squared?
same, same, same.
What is that? What happened to?
Okay, 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 okay.
The range of sine of anything will always be between -1 and 1.
Yes. Why did you write x? The only thing I don't get is why did you write x squared in the middle? X squared sine 1 over x.
Okay, so I
Multiply everything by
multiplied.
x squared.
Why not just
I
leave
multi
it limit on both sides?
No, I
Limit of
can't
x squared on both sides.
because I need to solve this limit. How are you going to solve this limit? I need this limit to appear inside here. So I multiplied everything by x squared, then I multiplied everything by limit as x approaches zero.
Oh,
Come on,
okay,
man, it's
okay,
easy
okay.
stuff.
I see. My
Instead of
bad, my bad.
solving this, solve those two. It's easier. And then the answer gets squeezed between both.
Yes, yes.
No need to do epsilon and delta. That's too difficult. Right, let's look at this one now. Limit as x approaches infinity of cos x over x. Now, if you substitute infinity, you're kind of gonna get infinity. I don't know. If you're gonna substitute infinity there, I don't even think you'll be able to solve it, right? So what we're going to do here is if you substitute infinity, your answer can be cos of positive infinity. We don't know. The answer can be between -1 and 1, and you're getting infinity here. We don't know what the answer is. So let's use squeeze theorem here, right? So you're going to say -1 cos x, right, is less than equal to 1. Okay. Now what we're going to do? We're going to divide everything by x, isn't it? Because I need it to look like this. So let's divide by x. -1 over x is less than equal to cos x over x is less than equal to 1 over x. Are we good? Now we substitute, now we push in infinity. Limit as x approaches infinity. 99% of the time, the answer is always 0 for squeeze theorem. Of cos x over x is less than equal to limit as x approaches 0 of 1 over x. And guess
Oh,
what?
Mr. Ghazali, sorry, why did you put the brackets in there for the cos x divided by x? Because limit x is is multiplied for both sides, no? You
No, I'm
didn't put
not
the
multiplying.
brackets.
I'm not multiplying. I need to make it look like this. I need to make it look like cos x over x. That's why I'm dividing by x now.
Oh,
Yeah.
okay.
Remember
Fine.
your ultimate goal is to find the answer for this. How are you going to find the answer for this? This part of the limit has to appear in the center. Okay.
Yeah, fine, I understand, yeah.
Right. Good. Right. Excellent. It's quite easy. All right. Now let's see. Now we're going to take the limit. So obviously when we substitute, sorry, it wasn't 0, it was infinity. Yeah, it was infinity. Limit as x approaches infinity is an infinite limit. Now look at this, -1 over infinity, that is 0, right? And there's 1 over infinity, that's also 0. So you just write hence by the squeeze theorem, hence by the squeeze theorem. Limit as x approaches infinity of cos x over x is equal to 0. Are we good, guys? You have to show that the answer is squeezed between left-hand side limit and the right-hand side limit are both the same. Right, so that's my answer as well. Now we come across something called L'Hopital's rule. Now, what is L'Hopital's rule? There are different forms of L'Hopital's rule. So this is how it's spelled. It's a mathematician's name, right? L'Hopital. Right. L'Hopital's rule. Now, what is
Tell me the
L'Hopital's
rules,
rule?
mister.
Wait, one second. Let me
I
go
know
slowly,
them by heart.
Right, excellent. That's good stuff. Right, look at L'Hopital's rule. The first type of L'Hopital's rule you get is when you directly substitute, you get 0 over 0, or you get infinity over infinity. In other words, you're substituting into a rational function. In this case, you got limit as x approaches a of f of x over g of x. So when you substitute a inside here, you're getting 0 over 0, or you get infinity over infinity. What happens
It's
in this
undefined,
case?
yeah?
Yeah. So basically what you're going to do is you're going to differentiate the top, differentiate the bottom, and solve the limit. So we're going to do it both ways. So let's look at
So,
the first
mister,
problem.
and it won't work when the denominator and the numerator have finite non-zero limits, right?
Yeah. Look at this. limit as x approaches 2 of x squared minus 2x over x squared minus 4. If I directly substitute, I'm getting 4 minus 4 over 4 minus 4. So what am I getting? I'm getting 0 over 0. Because I got 0 over 0, I must use different techniques. But now, remember, this is a very simple limit which we have solved. So what's the rule here? You create two functions. You say this is f function as that's a g function. You're going to differentiate the top and differentiate the bottom. So you're going to say by L'Hopital's rule. It's pronounced as hospitals. All right, so L'Hopital's rule. You have to say L'Hopital's rule. So what you're going to do here is you're going to say limit as x approaches 2 of d dx of x squared minus 2x over, show the rule, okay? That's why I'm putting d dx of x squared minus 4. Now I'm going to differentiate the top and differentiate the bottom. We are not applying product rule, quotient rule. You got nothing to do with product rule and quotient rule. It's just basic derivative. Differentiate the top, differentiate the bottom. So
Can
you're
I
just going to say,
differentiate?
and nothing changes with the limits. Limits does not change. Yes, differentiate, please.
Yeah. It will be 2x minus 2
Yes, over.
divided by 2x.
Right now, if I directly substitute 2, what do we get?
You will get 2 over 4.
You get 4 minus 2, 2 over 4, which is equals to half. So what's the answer for this? Half. Now, remember, we applied L'Hopital's rule because we found the indeterminate form as 0 over 0. Now, my question is, could we have done this without using L'Hopital's? Yes, of course, we could have factored out. Remember, when we did limits, I showed you factorization. So if you find the easier techniques, better. Unless you find 0 over 0 and infinity over infinity, then you can use L'Hopital's rule. So we got x squared minus 2x over x squared minus 4. So limit as x approaches 2. We're going to factor this out. We take out x into x minus 2 divided by x plus 2, x minus 2. Are we good? Difference of two squares. And then we cancel out x minus 2, x minus 2. We substitute 2 inside, we get 2 over 4, which is also equals to half. Both methods are correct. Okay? Both methods are correct because that's applying L'Hopital's. You found 0 over 0 is an indeterminate form. And the second one is just factorization. Great. What about this one? Part B. If I substitute infinity inside here, you can clearly see the answer. Same degree at the bottom, same degree on the top. So the answer is 3 over 2. Okay? Okay, Yahya? 3 and 2. The answer is 3 over 2. But you can apply L'Hopital's rule because when we directly substitute infinity inside, we get 3 times infinity squared minus 1, which is infinity. 2 times infinity squared, that's also infinity. So by L'Hopital's rule, we're going to get limit as x approaches infinity of d dx of 3x squared minus 1 over d dx of 2x squared plus 4. Right, so we differentiate the top.
6 over 4, yeah.
We're getting 6x
Oh, 6x over 4x.
over 4x. Now you can cancel the x's out. That's fine. And what's the answer? 6 over 4, which is 3 over 2.
3 over 2, yeah.
And that's what we discussed when we did infinite limits. Now I do have more examples on L'Hopital's rule, doing the same thing. Now let's directly substitute 1 here. If I directly substitute 1, I'm getting 0 in the denominator, and ln of 1 is also 0. How you know that? Ln of 1 is 0, right? Ln 1 is 0. So you're getting 0 over 0, okay? By L'Hopital's rule, applying L'Hopital's rule, we need to say d dx. Anyone knows what's the derivative of ln x?
1. Oh,
Yes?
it's
1 over
it's
x.
1 over x, sorry.
Yeah, take the x in the denominator and differentiate the x. Good. So we're going to say limit as x approaches 1. Now, remember in the exam, if you have to write it out, you must write d dx. I'm going to leave it out now because I'm just creating two functions, f and g. Okay, let's just write it out. d dx of ln x over d dx of x minus 1. Right, so derivative, still have to keep the limit. That's a nice thing. The limit doesn't ever change. So limit as x approaches 1 of 1 over x divided by 1. I can directly substitute and I can get an answer. 1 over 1, the answer is just 1. Great. Now, is there any other ways to solve this? No, there's no other ways. There might be other ways if you expand ln x using power series, but that's in BC. We don't need all that Taylor and Maclaurin series expansion. But this is the only way because we got the form 0 over 0. Are we good, guys? Next one. Remember, we did this limit before. Remember, I told you limit as x approaches 0 of sine x over x is what? The answer is 1. But I didn't show you a proof. So L'Hopital's rule gives a shorthand proof. If I substitute 0, sine of 0, so you're getting 0 over 0 again. Okay? So by L'Hopital's rule, guys, you can see how I'm structuring my answer. Everything must flow by L'Hopital's rule. Limit as x approaches 0 of d dx of sine x divided by d dx derivative of x. So we got limit as x approaches 0. What's the derivative of sine x? Cos x, correct? And what's the
Yes,
derivative
yes.
of x? 1. If I substitute 0 inside here, what's cos of 0? 1. So what's the
1, yes.
entire answer for this? Answer is 1.
1.
Excellent. Right, so I hope you guys are building your understanding now. What about this one now?
One question, sir, that I
Yes.
wanted to ask you before. What will be if it will be, for example, like 2 over 0? It will be same undefined, but it will not be the same rule in that case. For example, in the question.
So if you're substituting example limit as x approaches, good question. If you limit as x approaches 0 of 2 over x, you have a question like this. So now what you're getting
Yes,
is
yes.
2 over 0. All right, good, excellent. I like this question because now I'm going to make you think. So we're going to put this as an additional question. Right, so this got nothing to do with L'Hopital's rule. It's better to sketch a graph and check. This is a rational function graph. The graph is in first and third quadrant. Let's check the behavior at 0. So limit as x approaches 0 from the left. If you approach 0 from the left, it goes towards negative infinity. Right, the answer is negative infinity. And when you go 0 from the right, that 0 from the right is positive infinity. So it does not exist. Does not exist because you're getting two different limits as you approach 0. Do you
So is it the
understand?
same with infinity?
No. 2 over 0 is not infinity. You're getting
No,
two
no,
different answers.
I said 2 over infinity, like this. I'm saying, if, for example, instead of x, yeah, it
Okay.
will
If
be
you're saying
limited
2 over
to
infinity, the answer is always 0 because it's a very large number. 2 over negative infinity or 2 over positive infinity always approaches 0. It's always 0. Okay.
No, I about the limit x to 0, it will be 2 over x, same thing, but we're not putting 0 to bring the x until, not 0 until infinity. Is it gonna be same or something different?
You mean limit as x approaches 0 of 2 over x?
No,
Or
we'll
limit
check
as x
approach
approaches
0.
infinity?
Yes, like this.
Okay, yeah. That's easy. Then the answer is 0. Limit as x approaches infinity of 2 over x. If you directly substitute infinity here, what's 2 over something? What's 2 over 1 trillion? 0. That's easy. Okay. Whether it's
Okay,
positive infinity or negative infinity, this is just an infinite limit problem where the degree of the denominator is bigger than the degree of the numerator. The answer is always 0. All right, let's look at the
okay.
next one. Next one is when you substitute infinity, e to the power infinity is infinity, and infinity squared is infinity. So another indeterminate form of L'Hopital's rule. So we say by L'Hopital's rule, right? By L'Hopital's rule, you're going to find d dx. You say d dx of e to the power x, right? Over d dx of x squared. Now limit as x approaches infinity. What's the derivative of e to the power x? Still e to the power x. And derivative of x squared is 2x. Let's substitute infinity here. We can't cancel out anything. Again, we're getting infinity over infinity. So now you're going to repeat the same L'Hopital's rule process, okay? So you're going to say the answer is now equal to limit as x approaches infinity of d dx of e to the power x divided by d dx of 2x. So what we got?
Dx over 1. Dx over 1.
Limit, yes, limit as x approaches infinity of e to the power x over 2. Now if I substitute infinity inside here, you're going to get e to the power infinity over 2. So the answer is just equals to infinity. Are we good?
Yes.
Sorry, why did you, when you have infinity and infinity, okay, why did you re-get the derivative of the original function again?
Oh, no. This is derivative of e to the power x is e to
Yeah,
the
it's
power
this.
x,
It's,
right?
yeah, it's e to the power of x over 2x, which will give you infinity over infinity.
Infinity. So
Okay,
again, I'm getting
shouldn't
L'Hopital's
you
rule form.
take the derivative of infinity and infinity, which will be 0 over 0,
No,
which will
no,
be
no.
0?
You're not taking the derivative of infinity over infinity. You're taking the derivative of these functions, f
Again,
over
so you
g.
differentiate
Yes,
it again.
yes. You repeatedly do it until you get an answer.
Okay.
That's L'Hopital's rule. Now, guys,
Yes.
that was what was this indeterminate form? Dividing 0 over 0 or infinity over infinity. Now that was just one type of indeterminate form. What's the second type of indeterminate form? Indeterminate products. Okay? In other words, your answer is either 0 or infinity. Now watch here. Limit as x approaches negative infinity, this times this, right? X times e to the power x. So what's the answer? If I directly substitute, what's my answer here?
Infinity, just infinity.
No, it's going to be infinity and e to the power negative infinity. Okay?
Oh.
It's going to be negative infinity times e to the power negative infinity. That's almost 0. Okay? So we need to check, we need to convert this into L'Hopital's rule. So you're going to say by L'Hopital's rule, how can we differentiate this so we don't get issues? I mean, let's keep the x on top. You have to, whenever you're applying L'Hopital's rule, you have to change the function into f over g. L'Hopital's rule is f over g. So watch how I'm going to transform this function. I'll keep the x on top and move e to the power x down.
Negative?
Yeah, it becomes e to the power negative x. So I'm going to change the function like this, x over e to the power negative x, okay? Now I can say d dx of the top. Because now I have a f and g. Over here, I don't have f and g. That's f, that's g. So I'm finding the
Why
derivative of
can't
the
you write it
top.
as x over 1 over e to the power of x?
Same thing, e to the power negative x.
Yeah, but it would be easier for you to deal with positive numbers.
No, it's easier to differentiate e to the power negative x.
Oh,
1
yes,
over
yes.
8. Yeah, you just differentiate the power. Right, so d dx of e to the
Negative.
power negative x. So
Add-
now the derivative of the top
One.
is 1, and the derivative of the bottom is e to the power
Nega-
negative x times derivative of the top, which is negative 1. And by the way, this was negative. Yeah, now we can bring this up. There's nothing to differentiate now. Bring this up. I can take the negative out of the limit. Bring this up. That's e to the power.
Just x.
No, it's fine. No, it's fine. It's fine. No need to do that. We can keep it just like that. 1 over e to the power negative x. Now x is negative infinity. E to the power negative infinity is e to the power infinity. Yes. And 1 over infinity is 0. Yeah. Negative 0. So 0. Make sense, guys?
But look,
Mister, can you just remind me of the derivative of the underneath function? Because I forgot.
The derivative of e to the power x function is this.
Yeah, it's
You
supposed to
have
be
to remember
e
basic.
to the power of negative x. Why did you multiply by -1? I forgot that.
Good, good. D dx of e to the power f of x is equal to e to the power f of x times f prime. So if I
Oh,
differentiate
yes,
negative,
yes. I remember the
Ah,
rule now. Yeah, I just forgot
yeah.
it.
Right, great. You have to remember all rules. Now do the same here now.
So, Mr.
Yes.
Ghazali, sorry. Look, when you substitute the negative infinity in the original function, in the x, x, e, x, it will be also given as 0 here. But when you use the L, the name of that I forgot, the L.
Oh, yeah. So
it takes the same
1
zero.
second. So basically what I'm getting here is I'm getting negative infinity times 0. That's what I'm getting here. Negative infinity times 0.
It will be 0 here. Oh, actually.
You can't say that, but it's better to do a L'Hopital's rule to prove it, okay? Because it's indeterminate products. It's like 0 times infinity. It's like indeterminate product. See, like this one here. Ln of 0 from the 9. And now this is very important. If I substitute 0 here, this is 0 times what? Oh yeah, by the way, indeterminate product is 0 times infinity, not 0 comma infinity. 0 times infinity or positive infinity. Look here, 0 from the right of ln x. Now, if you remember the log function ln x is like this, right? 1 second, let me draw it on Desmos to get a better accurate
You see, the
graph.
answer for this will be 0.
Wait.
I
Don't
solved it.
guess. Chill.
I
I
solved it.
need a proof. All right, so let's see. Ln x. I want to check the function ln x. Okay, so I've got a graph like this for ln x, okay? I need you to explain everything. I need to check if it's an indeterminate product. Right. Now what happens limit, watch this example here. I want to check what happens when limit as x approaches 0 from the right. Well, you can only get 0 from the right because x has to be positive. The domain of the ln function has to be positive. So 0 from the right is what? 0 times negative infinity. So again, we need to apply L'Hopital's rule. So you're going to say limit as x approaches 0 from the right of, now how are you going to change this function? Let me take the x down and keep the ln x up.
Yeah,
Okay,
you would get
if I
ln
take,
x. Oh, yes.
let me take the x down so that becomes x to the power negative 1. And now then do ddx, okay?
Why? Just make it 1 over x over -1 over x squared.
No. I didn't differentiate as yet. Now I'm going to differentiate.
Oh,
So add
yes.
the ddx and then add the ddx, okay? So the derivative of ln x is 1 over x,
Yes.
and the derivative of x to the power negative 1 is negative 1 over x squared. Check ddx of x to the power negative 1 is -1 x to the power -2. So it's -1 over x squared. Are we good? That's what I put here. Now remember, 1 over x, and that can cancel out because this is -1 over x squared. 1 over x and 1 over x cancels out. So you are left with limit. What is -1 over x squared? It's -1 over x times 1 over x.
You
There.
just get negative x.
1 second. Limit as x approaches 0 from the right of -x, because 1 divided by, yeah. So now if you substitute 0 here, what's the answer? 0. So
Yes.
what
See,
is
I
my
told-
basic, guys, what is my basic argument here? The basic argument here is you can't always say that 0 times -infinity is 0. You can't say that. That's why we say it's an indeterminate form of L'Hopital's rule.
Mr. So
You have to
this can it
investigate
be
it.
solved without
You
a graphing calculator? Because I solved this with
Yeah.
my graphing calculator.
No, I don't need a graphing calculator. I was just showing you what the linear x function looks like accurately. I can draw a linear x function basics. You don't need a graphing calculator for this. I'm just showing you that the log function is on this side. It's a curve. It's an inverse of an exponential function is a log function. That's what I'm showing you. I did draw that initially, but I just wanted to give you a more accurate picture of what happens when limit as x approaches 0. The y value goes towards -infinity.
So
Right?
also, Mr. Ghazali, sorry, what will be in the case of addition or subtraction? We go with the multiplication and division, yeah, right now. But
Yeah,
what
yeah,
about
yeah.
the point?
No. We did division 0 over 0, infinity over infinity. Then we did
Yeah.
0 times infinity. Now we're
Yes.
going to do subtraction now. In the next
Oh,
indeterminate form is subtraction. When you have subtraction, again, change it to do LCD and change it to numerator and denominator. Remember, every L'Hopital's rule must be of the form f over g. You must have a function on top. You must have a function at the bottom. And you always come back to the first indeterminate form to apply the rule. Okay, let's see now. Over here, we're getting 1 over 0. What's 1 over 0? Infinity, correct?
yes.
We don't know. Let's check. Let's see. So we got infinity here. Whoa, 0, 1 over 0. Can be negative infinity or positive infinity. So because you can approach 0 from the left and 0 from the right. 0 from the left is negative infinity, 0 from the right is positive infinity. So it's plus minus infinity here. What about 1 over sine 0? Sine of 0 is 0, right?
Yes, yes.
So that's also kind of like plus or minus. Sine of 0 is 0. So you're getting 1 over 0. Yeah, so you're also getting like infinity. Just think of 1 over 0 to be like infinity is undefined. If it's
So
undefined,
just
it's like positive or negative infinity. That's why.
yeah,
1
it's
over
fine. Yeah.
0 can be positive or negative infinity. That's what I'm telling you. Same, yeah, plus or minus infinity. So that's why we're saying we have something like infinity. You can't say infinity minus infinity is 0, and you can't say, but infinity plus infinity. Infinity plus infinity is still infinity. But you can't say infinity minus infinity is 0. Okay. Now, what do we do with this? We make LCD and we make numerator and denominator. We don't have numerator and denominator. We have two numerators and two different denominators. We must make one denominator, one numerator. So we're going to cross multiply and get a function, which is x sine x in the denominator. And what's on the numerator? Sine x minus x. Okay, cross multiply. Are we good? So let's substitute 0 now. If you substitute 0 now, you're getting sine 0 minus 0 over, now we're getting 0 over 0. So you come back to first type of L'Hopital's rule. So by L'Hopital's rule,
Mister,
yes,
will we have to remember all these rules for the exam, or will some be given to us?
you have to remember all these rules. But you'll see, you'll get the hang of it eventually. Sine x minus, so you're going to say ddx of sine x minus x divided by ddx. Guys, be careful because we got x in the denominator here, all right? Mm, mm. Yo,
Mister,
you
before
know what we could have done?
you
You know what we
continue,
could have done? Yeah,
where did you get sine x minus x? I wasn't
this
really.
here, this here. LCD, cross multiply. Sine x minus x. How you do half minus quarter?
Mister, you can't cross multiply if they don't equal each other. They have to equal each other. The sign here is negative. How did you cross multiply if it's negative?
No, it's not
They
an
don't equal
equation.
each
Look,
other.
okay, class, I'm going to show you a basic algebra problem. This is all algebra, right? So if I tell you to take a quarter and minus 1/3, or take 1/3 minus quarter,
1/3.
1/3 minus quarter.
Yeah, I'd
So
put
what?
4/12 minus 3/12.
Wait. So 3 times 4. As long as the denominator is 3 times 4, then you can cross multiply. So 3 times 4 is 12. 4 times 1 is 4. 3 times 1 is minus 3. So 4 minus
Yeah, same
3 is 1
thing.
out of 2. That's what I did here. What's the difference between this and this? No
Yes,
difference.
same
Same thing I
thing.
did.
Yes, same thing.
Exact same thing I did.
Oh,
Okay.
yes. My bad,
All
my
right.
bad.
So ddx of x sine x. Now remember the derivative of the top,
It will be cos
cos
x,
x, good, minus 1.
and then
And
x cos x.
the derivative of the bottom is a problem because we need to apply product rule. It's product of two different functions.
Ah, yes.
Derivative of x is 1. Leave the sine x
Times
plus
plus cos
plus
x,
derivative of sine x is cos x
cos x.
and leave the x. Right, good. Now let's substitute 0 inside here. What is sine of 0? 0.
0.
And what's cos of 0?
1.
1.
1.
And then you got 0 here. Now we got a problem because cos of 0 is 1. 1 minus 1 is 0. And you're getting 0 again, 0 over 0. Do L'Hopital's rule again. Because you got another indeterminate form of L'Hopital's rule.
Ah.
Right, so cos of
Negative sine x.
All right, so negative sine x. خلاص, minus 1 is out.
Over 1 is out. The derivative of sine
Yeah.
x is cos x.
Plus,
minus sine x.
you got a
Plus
problem here
minus.
because you got a problem here because
Product
this is
rule.
product rule again. Derivative of cos x is negative
Minus
sine x
negative sine x times x.
times x plus derivative
Plus
of
1
x is 1
cos x.
cos x. Now, if you substitute 0, do we get the answer? Yes, we should because we got 3 different plus. Cos of 0 is 1. Sine of 0 is 0. So you got 0 on the numerator. Cos of 0 is 1. Sine of 0 is 0 plus 0
So again,
plus
yeah.
1. So the answer is just
Again,
0.
yeah.
0.
Huh? Yeah. Sorry? You're directly substituting now. We're not getting we are getting an answer. We're getting 0 over 2.
Oh. Oh, yeah. 0 over 2. Yeah, sorry. All right.
So خلاص, 0 over 2 is 0. So that's your answer for this. Does this here has an answer? Yes, the answer is 0. 0 is a finite number. Let's look at something like this now. Trigonometry, no problem. What is sec x? You have to convert this into fractions because we need
1
f
over
over g.
cos.
We need f over g. Good.
1 over cos will be, yeah. Minus sine minus minus cos.
1 over cos x minus
Sine
sine
over
x
cos.
over cos
Cos
x.
x.
Good. Right, now cos squared in the denominator. Wait, that's easy. 1 minus sine x over cos x. Because same denominator, you can just
Yes.
you can just
1
subtract the
minus.
numerator.
Yeah. Sine
Sine
x
x
over cos x.
What is sine of pi by 2? What's sine of pi by 2? Sine of pi by 2 is
Let me
1.
get the calculator, but I think it's 1.
1, 1,
It
1.
is
It's
1.
1, 1.
And cos of pi by 2
Is
is
1.
wait. Yeah, so
No,
we're
it's
getting 0
0.
over 0. 1
It's
minus 1,
0.
yeah, is 0.
It's 0,
0
0,
over
0,
0.
0.
So we're
Because
getting
19
L'Hopital's
Cos
degrees,
of
rule
pi
here.
by 2 is 1 or 0?
Cos of pi by 2, let's look at the cos graph, is 0. Is 0, yeah.
Yes,
Right.
yes.
Now, we find d dx, we're using L'Hopital's rule here, limit.
So it will just be cos
Wait,
x.
d dx, 1 minus sine x over d dx. Please write all this down, right? Because then the examiner will know that you are actually using L'Hopital's rule.
It's in the
Right, so
brain.
limit x approaches pi by 2.
Of
Right,
cos
derivative of the top.
x.
Oh, where's the negative? What's the derivative of sine?
Negative cos
sine
x over negative
Good.
sine x. You'll get negative cot x.
Why are you doing that? Why don't we differentiate again? Let's check. Directly substitute.
Where's my calculator? Wait.
Hey, wait. If you directly substitute pi by 2 here, the negatives cancel out. That's 0 on top. And sine
Or
of pi
1.
by 2 is 1. Yeah,
1.
so the answer is just 0. No need to do
Just 0.
L'Hopital's rule again. Yeah, so this is defined. All right, great. Guys, now we come to the last part of indeterminate powers. So all of these are forms of L'Hopital's rule. Look at this. 0 to the power 0, 1 to the power infinity, and infinity to the power 0. So they are, see, remember 0 to the power 0, indeterminate form. Or infinity to the power 0. You can't say 0 to the power 0 is 1. You can't say infinity to the power 0 is 1. And 1 to the power infinity. You can't say that that's also 1. Okay. So all the answers that give you 1 is not actually 1, right? It's indeterminate powers. 0 to the power 0, infinity to the power 0, and 1 to the power infinity. Okay. It looks like the answers are giving you 1, but because we have infinity and stuff, it doesn't, right? We have to actually check. Are we good, guys? So these are the 3 forms. Now, don't worry about these rules. I'm going to use something else. Right, so what we're going to do is I want you to look at something like this now. I want you to look at the transformation. So we're going to say, what is e to the power ln x?
Is E over, it will
Wait,
same,
one
no?
second. E to the power ln f of x. It's just f of
Oh,
x.
yeah. Just F
Inverse
of X,
function, they
yeah.
cancel. Or ln e to the power f of x. It is still f of x.
F of X, yeah,
Okay.
still.
Right. So remember these two. So what we're going to do is I'm not going to use these rules. There's an easier method. We're going to use e to the power ln and just solve this. I will always use this for all these 3 forms, indeterminate powers. Let's use this. And then solve the limit. So I only have 3 examples here. All right, so type 0 to the power 0. How we know is 0 to the power 0? Let's substitute 0 inside here. So, okay, we're getting 0 to the power 0. Now what? We take e to the power ln. See this function? We're going to take this function up with e to the power ln. So we're going to say this answer is now equals to, watch how we're going to solve it.
F of
We say
X,
there's
F of
a,
X.
wait, ln limit as x approaches 0 from the right of e to the power ln x to the power x. Are we good? You understood this so far? I just took
Oh, yeah,
f of
yeah.
x up.
Yes.
Now. Wait, I need to go over more rules because you forgot now. So remember, some of the rules that you need to know is the ln rule. What happens when we have ln a to the power b? The b goes in front of the ln, becomes b
You
ln.
have B ln A.
Good.
LNA.
So that's what we're going to do here. We got x to the power x. So we're going to move this x in front of that.
Oh, yeah, it's the power of power, yeah.
Yeah,
So
so
it will
0
be
from the right,
e to the power of x ln x.
x ln x. Now we can take a limit inside the power. We can move this entire limit on the power over there. And didn't we solve x ln x before? Is 0 times infinity, isn't? That part is 0 times infinity. So is that? So move the x down. We already did this limit. So I'm going to copy this limit. You only need to solve the limit on the power. Right, let's solve this limit here now. We're going to say this is now equals to limit as x approaches 0 from the right of ln x over 1 over x, isn't? And then we add the ddx. Derivative of ln x is 1 over x. We have done it before, okay? So don't act surprised. We've done this example before with the indeterminate products. 0 from the right. And this was derivative of 1 over x is negative 1 over x squared. And remember, we canceled that one out to that one, right? And we move the x up. And we said the answer is, if we move the x up, the answer is just 0. So what you got? This implies the answer is now e to the power 0. And what's the answer? 1. Are we good? Hello.
Yes, yes,
Yeah,
I
just-
understand.
Yes, yes.
This is the limit you are solving. You can say L, the limit that you are solving. So now the limit is e to the power 0. I only removed this part. I removed this part and I solved it down here separately because I have to apply L'Hopital's rule there. And I got this answer to be 0, which we solved before as well. And e to the power 0 is 1. Great. So you're not actually proving that 0 to the power 0 is 1, is because it's 0 from the right. That's why. Next
Mr.
one.
Ghazali, sorry.
Yeah.
One question. We're gonna make it same thing if we do, for example, in the limb, x equals to the equals to the what's the name? The infinity. It will be infinity. The power of infinity. We will use the same formula, yeah.
We don't have infinity to the power infinity is not an indeterminate form of L'Hopital's rule.
Oh,
Was it? What was it an indeterminate form? No, it wasn't. I think
no,
infinity to the power infinity. If you can have infinity to the power infinity, just be infinity, I think. It's not an
okay.
indeterminate form of L'Hopital's rule, okay? But I think
Okay.
you should be able to use L'Hopital's rule and prove that the answer is infinity. No issue. You do the
Yeah,
same.
it's fine. Okay. Okay.
Look at this
Understand.
now. How is this 1 to the power infinity? Because see, 2 over infinity is 0, isn't? 2 over infinity. So this is 1 to the power infinity. Can you see? So we're going to use L'Hopital's rule and we're going to say limit as x approaches infinity of e to the power ln 1 plus 2 over x to the power 3x. Now move the 3x to the front and move the limit there one time, okay? Uh, 2 over x. Great.
Mister, wouldn't it just be e to the power of a?
The 3 is causing a problem there.
Oh.
But I think, yeah, good question. Very good. You identified this as a E limit, so you can move the 3 outside. Yes, you're onto something. Excellent. I didn't think about that, but 1 plus 2 over x to the power x, and then you can take the whole thing cubed. So now limit as x approaches this is already e squared cubed. So the answer is e to the power 6. Excellent. Very good. But now let's prove it, that the answer is actually e to the power 6. You know what I did there? 3 times x is 3x. You understood that?
No.
It's a trick. Yeah, it's good. Yeah.
It's a trick. It's a trick. See, like if you say a to the power b to the power 2 is a to the power 2b. I just moved the
Exactly.
3. I raised the power to a power. Yeah. Because he identified this as Yahya identified this as 1 plus 2 over x to the power x as e e squared. So e squared cubed. Remember, the 3 can go on the outside. 3 times x is 3x. So it doesn't make a difference whether you write it like this or like this. It's a trick. Now, anyways, let's solve this. We got e to the power limit as x approaches infinity. Uh, 3x into ln 1 plus 2 over x. Now I need to solve this part, okay? And come to the same answer, e to the power 6. Very good, guys. Look at this. This is amazing, man. Use the e form. Excellent. Right, so let's see. Right, so I'm continuing this part because I need to solve the top limit. I need to solve the top limit here, right? So remember, take the 3x down better, or take the 3 out of the limit. And it'll be easier to solve. And move the x down. Keep the ln on top with dx.
What happened with the E, mister?
No, you keep the, I'm only solving the top limit. I don't know what the top
okay,
limit
okay.
is. And remember, I took the x down. It became 1 over x. Okay. Now, we have to solve this limit. Isn't this was ln? Yeah, what happened to my ln? I mean, I forgot the ln part here. Sorry. Remember, there's still a ln there. Derivative of ln of this. Yeah. Okay, so I need to differentiate this. Ln of this, so I'm going to say that's 1 over, not 1 over. What's the derivative of the inside? Negative 2 over x squared. And this part remains in the denominator. That's only the derivative of ln. This part here goes to the denominator. I differentiate this, okay? Derivative of 1 is 0. Derivative of 2 over x is negative 2 over x squared. That's only the derivative of the top. Now the derivative of the bottom is negative 1 over x squared. So great. There are some things that will cancel out and we can simplify, all right? Right, so I'm still not done with this, okay? What we can cancel out is, let's try to simplify this whole thing now. All right, so I got 3 times limit as x approaches infinity, negative 2 over x squared times this x squared moves up, right? Becomes negative x squared over 1. I still got that 1 over 1 plus 2 over x there. I need to simplify all this. So the x squared and the x squared cancels out. The negatives cancel out. 2 times 3 is 6.
Positive 2.
Yeah, so 2 times positive 2 times 3 is 6. 1 over 1 plus 2 over x. What's 2 over infinity? 0. And what's 1 over 1? 1. So the answer is 6 times 1. No need to apply L'Hopital's rule here. Substitute infinity inside here. What's 2 over infinity? 0. 1 over 1 is 1. So 6 times 1 is 6. So great. We got the answer for this limit. Call this limit equals to L. Call this limit L. So L is now equal to e to the power 6. Excellent. Look at this. We identified an e limit. So that's why we say you don't even. Yeah. So now the answer is L equals e to the power 6. All right, guys. Excellent. So see how short this was instead of doing this. But as I said initially when I was doing example 1, I told you, you don't need to remember the E rule. If you do remember it and you identify the form, you don't need to apply L'Hopital's. But we applied L'Hopital's indeterminate form and we still got the same answer. Right.
So
let's look at the last form
exam,
now.
In the exam, we can use the left formula for the E rule in the exam.
Yeah, you can. It's perfect.
It's fine, yeah? Okay,
Yeah.
okay.
Next one. Look at this last one now. Is it infinity to the power 0? Yes, it is. Infinity, 1 over infinity is 0. So it is the type infinity to the power 0. Now let's solve using the exact same technique. So we're going to say e to the power limit, limit as x approaches infinity, e to the power ln x to the power 1 over x. Now this is nice. This will work out easier, right? So I'm going to move the 1 over x in the front. Okay. And now move the limit inside and call this limit L. Right. Now, let's solve this. Is this, just solve the top part, solving the power. What is this? Is this infinity over infinity? Ln of infinity, yeah. So we're getting infinity over infinity. So d dx, d dx, okay? So let's add the d dx. You shouldn't be adding the d dx here. You should add it in the next step, right? Just need to make some space here. d dx, d dx. Now, derivative of ln x is 1 over x, right? And derivative of x is 1. And if I substitute infinity inside here, 1 over infinity is 0. So what's my
0
limit?
over 1.
E to the
0.
power 0, which is equals to 1.
1.
Perfect. Right, excellent, guys. So now what did we learn in L'Hopital's rule? There are 4 indeterminate forms. All right, so in L'Hopital's rule, the power forms, what do we use? We just use e to the power ln f of x, okay? All these 3 power forms. Infinity minus infinity, what do? We do denominator. We make a rational
Denominator.
function. Make a rational function. And remember, this is your main rule. You must get 0 over 0 or infinity over infinity. You have to get this to apply derivative on top, derivative at the bottom. Indeterminate powers products is 0 times infinity, okay? For 0 times infinity, you need to take one of the functions in the denominator, one on the numerator. You have to convert to f over g. Right, that's it. Okay, guys. I'm going to end the session now. I hope you understood everything.
Alhamdulillah, yes, sir. Thank you.
1 second.